Well, after we've spoken about the temperature of the Earth, now we need to speak about the water on the Earth. When we talk about water or fresh water, this is for our drinking water, it's for our agriculture, for our ecosystems, and so we need to know where this water is coming from, where it's going, the resources we have. And here we can see this on this diagram, what we call the hydrological cycle. The hydrological cycle is the cycle of water in the atmospheres, in the ocean, on land. And most of our water originates in the oceans, evaporation from the ocean, but also evaporation from plants, which are transpiration from plants. We have transport from the oceans to the land, from the land back. As the air goes up, we also have clouds forming, and eventually rain will produce water, which will fill up our lakes and our rivers. Some of this will seep into the ground, to the aquifer, the water table, and some of this will run off back into the ocean. So we have this balance between water in the system. We have a finite amount of water, but we have this cycle which is continuously taking water from one place to the other, whether it's through the atmosphere, whether it's on the land. And overall we have a balance, although in some parts of the world it's drier and other places it's wetter. If we actually look at the amount of water we have on planet Earth, 70%, 71% of the planet is covered by the oceans. So we have most of the water, 71% of the surface is covered by seawater. We can't use that really for drinking, although now we do have desalination. A small fraction of the water we have is sweet water, only about 2.5%, but most of this is frozen in ice, in the ice sheets in Antarctica, in Greenland. And so this too is difficult to use. And only a very small portion of that 2.5%, maybe 1% of the fresh water, we actually have as readily available water in lakes, in rivers, that we can actually use for drinking water. So a very, very small fraction we can actually use for drinking or for agriculture. We can see that also here in this plot showing on the left the total global water, and we can see that again, most of it, 96.5%, is in the oceans, salt water. Not very easy to use that. A very small fraction, we see 2.5 at the top of this, is the fresh water. We can then zoom into that 2.5 in the middle column, and we see that, again, out of that 2.5%, nearly 70% are frozen in our glaciers and ice caps. Another 30% is in underground water, and only a very small amount of that, 1.2% of the 2.5, is surface and fresh water in lakes and rivers at the surface that we can tap into. And if we zoom into that 1.2%, we see that, again, most of this is frozen on the surface, whether it's mountain glaciers, in frozen land, what we call permafrost, lakes, and then we can see a very small amount at the top, which is also in the atmosphere, if we're looking at the water in the whole system. And that small fraction of water vapor in the atmosphere, 3% of the 1.2% of the 2.5%, is what gives us all of our rain and all of our clouds in the atmosphere, all of our storms, our hurricane. All of that water is in this tiny little fraction that we have in the atmosphere, but has such large impacts on our lives, whether it's flooding, whether it's storms, or whether it's water for our agriculture. In this figure, we can actually see the hydrological cycle where we have the reservoirs shown in the boxes. So on the top, we have the reservoirs in the atmosphere, the continental atmosphere shown in the blue, and in green, we have the maritime atmosphere, how much water we have above the land and above the oceans. And these are given in units of 10 to the 15 kilograms. So this is the mass of water we have in this reservoir. And if we look at the surface, we also have reservoirs in the land, in underground water, ice and snow, surface water, and in the oceans, where we know that the oceans, we have different layers, but the oceans, you can see the number here, is much, much larger than the other reservoirs. So we have these 4 different reservoirs with huge amounts of water, and the arrows show the fluxes, the motion of water from one to the other. So first of all, we have rivers which are taking water back to the oceans. We can see these units are in 10 to the 15 kilograms per year. So this is a flux, how much mass is changing over a period of time. And we see that the motion from the land to the oceans, 36 units, is the same as the motion from the atmosphere over the oceans to the atmosphere over the continents, 36 units. But when you look at the arrows going up and down, the evaporation and the precipitation, these are not equal over the oceans and over the land. We see a lot more evaporation over the oceans because they're simply much larger in area. Some of that water which is evaporated into the atmosphere is then taken with the winds over the land and falls as precipitation over the land. And therefore we actually have less precipitation going back into the oceans and more precipitation going over the land relative to the evaporation which is leaving the land and going up. But if you add these numbers together, you'll see we have a balance, and we have a continuous balance of this hydrological cycle.